Hi boys and girls, and welcome upstairs to my house. We've been filming in the basement this entire time, but I thought I'd bring science upstairs today because I want to show you that science is all around us and it's even found in your own home. So it's everywhere. So today we're going to talk about chemical and physical changes and how they are alike and how they are different. Everything is made up of matter. This bowl is made up of matter. This lime's made up of matter. Murphy's made up of matter. I'm made up of matter. You're made up of matter. Anything that takes up space is matter. So today we're going to focus on chemical and physical changes. And we're going to talk about the two ways that they change matter. First, we're going to talk about a physical change. You've already read about physical changes. As you read about them, you notice that it was when matter changed, but it was still made up of the same matter. What do you mean, Mrs. M? Well, what I mean by that, guys, is take a look at the loaf of bread I have in my kitchen. This is bread. It's made up of different elements, and it's matter. But if you look at my bread, you can see it's been sliced. Is cutting the bread a physical or chemical change? Well, what makes a physical change? A physical change is when it changes the appearance of an item, but doesn't change its makeup. By slicing the bread, I made smaller slices, but it's still made up of the same matter. So this would be a physical change. Over here, I have a glass of water and I have an ice cube. If I were to put this water in the fridge, or the freezer, this would be the result. As you can already see, it's been sitting out on my counter and it's starting to drip. Is this a physical or chemical change? Is it changing the makeup of the water? Is it still H2O? It is. So this would be a physical change. If this was to melt, and it's going to, I could put it back in the freezer, and in a few hours, I'd have an ice cube again. So it's a physical change. Look over here at my counter. I have some bananas. I bought these, I think, on Friday. If you take a close look at them, you're starting to get some brown spots on them. What is that? What are the brown spots on the banana? Well, they're getting overripe. So we have to eat these soon. But what happens when a banana gets too ripe? Is it a chemical or physical change? Well, does it change the appearance of the banana? It does. But it also changes the chemical makeup. Once a banana goes ripe, you can't fix it. It can't go back to its original state. That's the difference between a chemical and a physical change. A physical change is still made up of the same things, but a chemical change makes up something entirely. And today we're going to talk about that. If you look here on my counter, I've gathered some ingredients. We are going to have our own chemical change in the kitchen today. I've gathered up some bread flour, some sugar, honey, a packet of yeast, and some salt. With just these basic ingredients and some water, we are going to make a chemical change. We are going to make bagels. Well, we're going to try and make bagels anyway. Mrs. M loves to cook. Cooking is so much fun. It's very relaxing for her. Mrs. M is not good at baking. There's a difference between cooking and baking. Baking is a science. Baking is chemistry. It's just with different terms. You have to be exact. You have to use tools and measure. If you don't put in the correct combination, you will not get the correct product. With cooking, it's okay if you put a little bit more of this in or a little bit more of that. You can be a little more relaxed. But with baking, it's a science and you have to be precise. So we're going to talk about how to make a bagel and we're gonna see if this turns out. Okay, boys and girls, we need to get 1.5 cups of warm water. This is gonna activate the yeast. It's actually gonna be a chemical reaction within a chemical reaction. The water has to be warm. And as you can see on my measuring cup, it's also a little math involved. We have ounces, cups, quart is a whole one of these. So how many cups equal a quart? Anyone remember? It's 4 cups. Okay, so we need 1.5 cups. So I made sure I measured that. Now I'm going to put it over here in my mixing bowl. And I'm going to add 1 3/4 of a teaspoon of yeast. Now on the back of this package, it says 1 packet equals 2 1/4 teaspoons. So I'm gonna have to do a little measuring. So the first thing I'm gonna do is I'm gonna make sure that that is an accurate measurement, because when we are measuring, we have to be precise. And we went teaspoons. Did you see what Mrs. M did wrong? I didn't use teaspoons, I used tablespoons. I was like, wait, that doesn't work. So I'm gonna pour that back in here carefully, and I'm going to use the right tool for the job. So I need to look for the one that says teaspoon, which is the blue one. Okay, TSP, remember? So we are looking for 2 3/4. So we're gonna count this out. And this is one thing Mrs. M can't do when there's a lot of people in the house. I can't count because I lose count because I'm too busy talking to everybody. 2. And you know what? It's not even really 2. Could be because it's stuck to the sides of the bag. Could be that Mrs. M, when she made a mistake, it's stuck in the other one. But we're going to have to use 2 packets. Okay. So 2. And again, we have to be very precise. Mrs. M has never done anything with yeast before, so this is rather interesting. And 3/4. So I'm going to use the 1/2 and the 1/4, because when I add up 1/4 and 1/2, it's going to equal 3/4. Here's my 1/4. And, oh, check that out. The static electricity from the bag made it stand up. That's pretty cool. I don't think that's full. Oh, there we go. Okay. So now I'm going to set that aside because I can use this when I do another bread project, if I do another bread project. I'm going to lift up my mixer. I'm going to swoosh that around. I'm going to put this on. I'm going to use my bread hook. I'm going to lock it into place, and very slowly I'm going to mix that up. Okay, boys and girls, we're going to start making our bagels to see our chemical change. So I need to add 4 cups of bread flour. Now notice how I'm doing this. I'm using a spoon and putting it in here so I can be more precise about my measuring. Now, before I started, I did wash my hands thoroughly and I sanitized my counter. And the reason why that's important is we're going to be rolling the dough on the counter and we don't want to have a mess. You're going to take a knife and, starting in the back, you're going to go forward, and Mrs. M is a messy baker, as you can see on the counter. We're going to measure 4 of these. Okay, now that we've got our 4 cups of flour in our bowl, we're going to add our salt and our brown sugar. We need a tablespoon of brown sugar. And just like we were precise with our flour, we have to be precise with our sugar. Even though it would probably be yummy to add more, it would change the chemical makeup of the bagels and they may not cook properly. So there's our 1 tablespoon. And then we need 2 teaspoons of salt. It's measuring into my mixing cup that's gonna be cleaned up anyway. Okay, I'm just gonna set this aside so it's not in our way. So we got our dry ingredients in our bowl. And after we put our dry ingredients in the bowl, we are going to beat it on low speed for 2 minutes. We're going to prepare the dough. We're now going to whisk in the yeast and the water. Okay guys, we're back. And I've been letting the yeast in the warm water sit in the bowl covered. And before I take off the cover, I want you to take a look at it. If you notice, you can no longer see through it. And the reason why you can't is the gases have been released. And that's one way to tell it's a chemical change, is if a gas has been released. The gases have been trapped on top of the plastic wrap. So I'm gonna peel it off. And when I do, and Katie puts the camera inside the bowl, you'll see all the little air bubbles that have formed. Okay. All right. Now we're going to, I'm just going to move the hook because it's going to be easier for me. We're going to add our flour and our salt and our brown sugar. Carefully. Sort of. Okay. Salt's a little. That's not bad for Mrs. M. All right. Now, I'll put the hook back on. And we're going to do this on a low speed for 2 minutes. It's been mixing for 2 minutes now, and as you can see, it's changed its consistency. Now, at this point, it is not a chemical change. The chemical change did happen when the yeast bloomed and it gave off gases, but this bread dough itself is a physical change. If I were to leave this on the counter, it is not going to change its chemical makeup. It is not going to change its chemical makeup until I add the heat element, which is the baking. So I'm just gonna, this is a messy part, and Mrs. M is not one to like messy hands. So again, this is not really her favorite part. But I did dip my spatula in flour on the counter before I went ahead and I put it in here because it's going to be very sticky. As you can see, I floured the counter again. I cleaned the flour before. Now this recipe yields 8 bagels, which means we'll get 8 bagels out of this dough. If you look at the size of the dough, which I just said to Katie, I said, there's no way I'm going to get 8 bagels out of here. But I forgot another step. This is why it's so important to follow directions when you bake. One of the things I forgot is we have to let it sit. We're going to let this sit on the counter for 90 minutes. That's an hour and a half. Again, we're using those math skills and our science skills until it at least doubles in size. So we're going to do that. So I think I got majority of the dough. I don't want to miss any of it here. It's very sticky. Very, very sticky. Okay. So I'm going to set that aside. Flour my hands again. Clean hands. Very important. Okay. I put the flour on my hands because I don't want it to stick to me. And there's flour on the counter because I don't want it to stick to the counter. So what I'm doing when I'm kneading the dough is I'm incorporating all the ingredients together some more. This would have killed the mixer because it's such a thick dough. And I'm making sure that the yeast gets all the way through the dough. So I'm going to do this for 4 or 5 minutes. Okay, boys and girls, our dough has been thoroughly kneaded. Lauren gave me a hand, I was getting tired. And we have a ball of dough. Again, still a physical change. It is still the same matter. The yeast itself overwent a chemical change, but the physical change is all that has happened at this point. Until it gives off gas, until it changes in color, until it's given off light, or until heat is added or taken away, can it be a chemical change. I have oiled a bowl, and I'm going to put this in here, and it said to roll it in there, which I just did. And now I'm gonna cover it with saran wrap, and it's gonna sit on the counter for 90 minutes. Bread making is a very time-consuming process. You know, I don't have the patience to do this all the time, but we have time on our hands. So I'm gonna go ahead and cover this, and hopefully, fingers crossed, pray to the saint of baking, I don't know who that is, that we will have our dough doubled in size. So it should be up to here when I come back in 90 minutes. Okay, boys and girls, we are back. We have been gone an hour and a half, and what we have here is our dough that has rusted. And if you look at it, you can see, once again, there's condensation on our plastic wrap, which tells us that a gas was emitted, and our dough has risen to double its size. So we did it right. This means a chemical reaction has occurred because a gas has been omitted. Now, we are going to put this out onto the counter. Again, I washed my hands, I've washed the counter, everything is sanitized, and we will divide this up into 8 parts. Again, math is playing a role in our science. So I'm just going to, it doesn't say to punch it down. I read through the directions a couple times, and I don't see, it says after the dough rises, it's time to shape them. First, divide the ball and dough into 8 equal parts. So we're just gonna pour it out. Looks good, guys. Looks like we did a good job. And it's starting to deflate a little because those gases are going down. I'm just gonna put my knife in some flour here. First thing I'm gonna do is I'm gonna divide it in half. So I have 2 equal parts. And it doesn't have to be perfect, this part, but you wanna make them as even as possible because of the cooking time. And then from each part, I need to divide that into fourths. So I'm going to divide it again in half. Maybe. And then, probably dip my knife back in the flour. And then each of those halves I'm going to divide in half. So I'll get 4 out of each half, so that would be a total of 8. While I'm doing this, I have some water on the stove boiling, because to make a bagel, it has to have a crust on it, and part of the process is boiling it, which will cause the gluten, which makes the bread stretchy, to have its final chemical reaction by boiling it. Okay, we have our 8 semi-circles. So I'm going to pick them up. I'm going to make them into balls. I'm not going to handle it too much, because if I handle it too much, I'm going to lose all those air bubbles. And those air bubbles are what we want for our dough. It'll have those, when you bite into it, you'll see all the air bubbles that show where the gases have escaped. Okay, so I have my dough ball. I'm going to take my thumb, because the important part of a bagel is the center, right? Okay. So, and I'm just going to put it over here on my mat while we wait for our water. Okay, so I'm going to pause here and we'll pick up when it's time to boil them. Okay, boys and girls, I had my water boiling. I went ahead and I added a 1/4 cup of honey to the water and whisked it in. And the reason why you do that is not so that it'll make the bagel sweet, but it's actually going to give the bagel its color. It's going to caramelize. So changing color, again, is another one of those chemical reactions. So once the water comes to a boil, we're going to take our shaped bagels here, and we are going to put them in the water, and they're going to cook for 2 minutes. So I've got room for 2 bagels, and that's all I'm going to put in there. And I'm going to let that go for 2 minutes. I'm going to set my timer. Make sure I don't lose my hole there. And once those are done, we'll do another 2 and so on until we're done with all 8 of them. Okay, I have had my bagels boiling for 2 minutes. I'm going to take them out of the water. I'm putting them over here to my station where I'm putting flavors on. This doesn't have anything to do with a chemical change, but it's just so they taste a little different. When we read Jalapeno Bagel a couple weeks ago, they talked about their favorite flavors of bagel. Mine happens to be the everything bagel. And this is from Trader Joe's. If Mom and Dad go to Trader Joe's, they have an everything bagel seasoning, which I love. So I'm putting these on our cookie sheet. Once I have them flavored, I have 1 more to get out of the water. Then we're gonna put them in the oven for 20 minutes where it will undergo another chemical change. I am brushing the bagels with an egg white so that the toppings stick better. You can put anything you want on a bagel, as we read in Jalapeno Bagel, but I did 2 plain because Lauren doesn't like anything on her bagel. I did 2 salt and 2 everything and 2 sesame seed. So there's not much left. We'll just finish it up in there. Okay. So we're gonna put these in the oven, and hopefully in 20 minutes we'll have some yummy bagels that I'll get to share with you. Okay, boys and girls, I've pulled our bagels out of the oven. It said that they were gonna be done in 20 minutes. I kept them in a little bit longer because they felt kind of soft. As you can see, another chemical change has occurred. We have a caramelization, which gives us the color. So when we have a color change, that is a chemical change. When we rip into one of these, which we can't right now because they're nuclear hot, you'll see the bubbles where the gases have been omitted. Again, another chemical change. And we applied heat, which makes it another chemical change. This started out as a dough and it became bread. Therefore, it was a chemical change because the matter cannot go back to its original state. There are many chemical changes and physical changes all over your house. I just want you guys to open up your eyes and take a look around. Science and chemistry is everywhere. And sometimes it's even yummy too. I found this recipe on Pinterest. There's also the jalapeno bagel recipe in the back of your reading book. If you and your family do want to try to make bagels, it does take some time and some patience. So pack both. I hope you guys enjoy this chemical change, and we'll talk to you soon.